Hello, I welcome you all. The problem reads disk A has a mass of 2 kg and is sliding forwards on the smooth surface with a velocity of 5 meters per second. When it strikes the 4 kg disk B, which is sliding towards A at 2 meters per second with direct central impact. If the coefficient of restitution between the disks is 0.4, compute the velocities of A and B just after collision. So this problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. So we are dealing with impact, and impact here occurs when two objects collide with each other over a very short period of time, causing relatively large impulsive forces that interact between the two bodies. Right, so what do we do here? So let's add a bit of details here. So we do have MA here, the mass here. We've been told this is 2 kg, right? And then the mass here is equal to 4 kg, right? What else? And then taking this as a reference, I want to take this as a reference. This is our positive. So this is our y and this is our x, right? So considering the system of particles, then we can use the conservation of momentum. All right, so we do have here MA VA1 plus MB VB1 is going to be equal to MA VA2 plus MA MB MB VB2. All right, so adding numbers to this, we'll have a 2 like so, and then by 5 plus we have a 4 VB, which is going to be minus 2. Okay, mind you, it's going to the other direction, right? And this is just going to be equal to 2 VA2 plus MB, which is 4 VB2. So if we worked out this just becomes a 10 minus 8. So this just becomes a 2 is equal to 2 VA2 plus 4 VB2. So this becomes our first equation. Assuming VB2 is greater than VA2, then our E is just going to be equal to VA2 minus VB2 minus VA2 divided by VA1 minus VB1, and this we've been told is equal to 0.4. Therefore, 0.4 is just going to be equal to VB2 minus VA2 divided by VA1 is 5 minus VB, this one is going in the opposite direction, so it's going to be minus 2. Okay, it just gives us VB2 VA2 divided by 7. Therefore, this just becomes 7 by that, becomes a 2.8, right? 7 by 0.4. So this just becomes equal to VB2 minus VA2. And this is our second equation. So writing this, we'll have VB2 is equal to VB2 is equal to 2.8 plus VA2, and then this just becomes a 2 is equal to 2 VA2 plus 4 2.8 plus VA2. Therefore, our VA2 is just going to be equal to, so we have 2 plus 4, okay, and then we have 2, we do have 2 there, and then we have 2 there, and then minus minus 4 times 2.8, okay, and divided by answer, this is 1. So 2 minus 4 by 2.8 and divided by 6. So this gives us a minus 1.53 meters per second. So it means VA2 is going to go this side. So this just simply means, therefore we can say VA2 therefore is 1.53 meters per second, and is going in the opposite direction, which is this direction, like so. Okay, and then we do have our VB2. Okay, our VB2 is there we go. So this becomes a 2.8 plus the 1.3 there. So this one we get a 1.27 meters per second, and therefore our VB2 is just going to be equal to 1.27 meters per second, and it's going to go in this direction like this. All right, so then energy itself, so we have summation of energy itself from 1 to loss of energy, which is just equal to a difference in the kinetic energy, and this is just going to be equal to the summation of half m v2 squared minus summation of half m v1 squared, and this is equal to half by 2, I mean by 2 by, this is a 1.53, okay, squared plus half by 4 by 1.27 squared, and minus, and we have half by 2 by 5 squared, okay, plus half by 5 by 4 by 4 by 2 squared. Therefore, this loss in energy just going to be equal to this loss in energy is equal to, so we have 0.5 by 2 by 1.53 squared plus 0.5 by 4 by 1.27 squared, 0.5 by 2 by 5 squared plus 0.5 by 4 by 2 squared. So we have minus 27.43 Newton meters or joules. Okay, right. So 0.5 by 2 by 1.53 squared plus 0.5 by 4 by 1.27 squared minus 0.5 by 2 by 5 squared plus 0.5 by 4 by 2 squared, 2743. So this is the loss of energy. Where we're asked to find, right, so this one we are not asked to find, we just calculated it. Okay, so there we go. So we have found these velocities here, and these are the directions. Okay, and this is also here the loss in energy. All right, so I hope this particular video is helpful. And if it was, give me a thumbs up, like my video, and continue subscribing and liking my channel. Bye bye, and see you in my next screencast.